All right, I want you to think of yourself as a data detective. See, every single data set is a scene, and it's just packed with clues. Your job? To piece it all together and uncover the story. And today, we're cracking open the essential toolkit for pretty much any investigation, the Python library known as Pandas.
And really, that's the whole point, right? Every single spreadsheet, every database, it has a narrative just buried inside of it. Pandas is the language we use to actually listen, to understand what that data is trying to tell us.
So, where does any good investigation start? Well, you've got to gather the evidence. For us, that means loading up our data and getting that first look at the case file.
You know, when you first get a data set, it can look, well, like a total mess. It's just a jumble of clues. So before we can even think about finding insights, we've got to organize it into a structure that we can actually work with.
And that structure? That's the Pandas data frame. The best way to think about it is like a spreadsheet on steroids that lives inside your code. It's built to handle huge amounts of information, and it makes the really tedious parts, like cleaning and filtering, so much easier.
And you might think getting all that data in is complicated, but check this out. It's incredibly simple. Literally one line of code is all it takes to pull in data from something common like a CSV or a JSON file, and boom, it's in a data frame, ready to go.
Okay, so our case file is officially open. First order of business, a little reconnaissance. This is where we get that quick, high-level overview of our evidence before we really start digging in deep. The first command you'll probably ever run is .head. It's like flipping open the case file and just looking at the first 5 or so entries. It immediately gives you a feel for what the columns look like and the kind of data you're dealing with.
And, you guessed it, .tail does the exact opposite. It shows you the very last few lines of your file. This is a super quick way to make sure everything loaded correctly, and that the end of the file looks just as good as the beginning.
All right, now let's check the vital signs of our data set. .shape tells you the size, how many rows and columns you have. .columns just lists out all the column names for you. And .info, .info is awesome. It gives you a quick summary of what kind of data is in each column and, crucially, if any data is missing. It's like a 30-second health check.
Oh, this next one? This is a game changer. The .describe command is just a powerhouse. With this one command, you get an instant statistical profile of your evidence. For example, a marketing analyst could use this to see the average customer age, the highest purchase amount, and how much spending varies, all in one go.
Okay, so we've got the big picture. We know the lay of the land. Now it's time to pull out the magnifying glass and zoom in. We're going to start filtering our data to isolate the specific clues that really matter.
So the most fundamental way to filter is just to ask a question, a true or false question. Here, we're basically saying, hey, data frame, show me only the rows where the value in the mark column is bigger than 80. It's simple, but it's the foundation of everything.
Now, to get really specific, you've got two main tools, .loc and .iloc. This can be a little confusing at first, but it's actually super simple. Use .loc when you know the label or the name, like the column name mark. Use .iloc when you know the integer location, or position, like the very first row and the third column. So loc for label, iloc for integer location.
But let's be real, investigations are almost never that simple, right? You usually need to connect a few different clues. For instance, what if you want students who scored over 80 and are in Class A? You use the ampersand for and. What if you want students who scored over 80 or under 20? You use the pipe symbol for or. This is how you start asking really complex questions.
So far, we've been looking at individual clues, right? Individual students, individual sales. But the real story, those aha moments, they come from finding patterns. And to do that, we need to group our evidence together to see that bigger picture.
And the core idea behind this is a beautiful little strategy called split, apply, combined. It's exactly what it sounds like. First, you split your data into different groups. Then you apply some calculation to each of those groups, like finding the average. And finally, you combine all those results back into a new, tidy summary.
And look at this. This is that exact strategy in one clean line of code. We tell Pandas to group by the class column. Then we say we're interested in the mark column. And finally, we tell it to calculate the .mean. And just like that, you have the average score for every single class. Powerful stuff.
But what if you want to know more than just the average? What if you want the average and the highest score per class? Well, that's where AG comes in.
It lets you run a whole list of calculations, aggregate them all at once so you can get the mean, the max, the min, the whole shebang in one go. Super efficient.
Okay, this next part is absolutely crucial. Before we draw our final conclusions, before we present our findings to the jury, so to speak, we have to be 100% sure our evidence is clean and reliable. Data quality is everything. So, data types. You're probably thinking, why do we even care? I mean, does it really matter if a number gets stored as text? And the answer to that is a huge, emphatic yes.
Oh yeah, it matters. It matters a lot. Just look at this. If your numbers 75 and 5 are stored as text, adding them together just sticks them next to each other, and you get 75.5, which is obviously wrong. But when they're stored as actual numbers, you get the correct answer, 80. This little detail can break your entire analysis, so it's a step you can never, ever skip.
The other big mess you'll always find in your data is missing values, those annoying empty spots. You've basically got three options. You can find out how many you have, you can just drop any rows that have missing data, or, and this is often the better move, you can fill in the gaps with something logical, like the average value for that entire column.
All right, for our last major step, we're going to do what all the best detectives do, combine evidence from different sources. Because sometimes the full story only comes into focus when you bring multiple case files together.
And for this, you've got two main tools. Think of pd.concat as just stacking files. You take one data frame and you put another one right on top of it or next to it. It's great for just adding more rows. pd.merge, though, is much smarter. It's like an SQL join. It looks for a common column in two different files and intelligently links them together. This is how you connect student grades to, say, student attendance records.
And just like that, our investigation for today comes to a close. We've gone through the essential tools every data detective needs in their kit, and I want to leave you with this quote from B.B. King. The beautiful thing about learning is that nobody can take it away from you. The skill you're building here, this ability to find the story hidden deep inside the data, that's a skill that's yours forever.